So our last video ended a little abruptly. My internet started doing something weird. So we were talking about and learning about net present value. So we're going to continue that, okay? We're going to learn more about net present value, look at it another way, and then we'll end the video and move on to internal rates of return. So I'm going to kind of pick up back here a little bit before we left off, right? So just a reminder, we had just calculated the net present value for, let me go back to that real quickly. So we had done, we did this, all right? So here's what we did. We were working on a, contract, and it's going to pay us $80,000, right, every year, right, annual in, right, and we were going to have some cash flows out at the beginning, right, our initial investment, and we're going to get these cash flows in, and we'd have a little cash flow out here, 30,000, and at the end we'd sell the equipment, and at the end we'd get our working capital back. So what we did was we took each of these cash flows, right, and we discounted them to the present value. And by discounting, I mean we looked up the discount factor. So depending on what year it was, we used this at 11% was our return, and we have different years here. And we went to the present value table for $1 or the present value table for an annuity, and we came up with these factors. All right. Now, not so much for right now, because you don't really discount right now, right? So for now, the factor is 1. But we looked up the annuity factor, right? And well, we didn't really look it up. I just told you could, but I think I'll show you how to look it up now. So in your book on page 687 and 688, there are these charts. I just go out to the internet and click present value of an annuity, 11%, or I probably would go in Excel and type equal NPV and do that. But in your book, they give you a chart. So let's take a look at that. I'm just going to share my whole screen here with you. And we'll go look at these charts. I've got my McGraw-Hill ebook here. And so in your ebook or your real book, if you go to page 687, what you will see is this present value table. All right, and so this is present value of $1. I don't know if you can see it up here at the top, but it says Appendix 14B, present value tables, Exhibit 14B1, present value of $1. And then it gives you the formula, right? It gives you the formula to do that. All right, so this is what tells you its present value of $1. See how it says $1 there. All right. And here's your table. So you find the period. So in our year 5, right? So we were doing a present value of $1 in year, I think we had to look up year 5 where the salvage value was. So we did year 5, and then it was at 11%. So there's our value, 0.593, okay? And for the annuity, for the $80,000 that we got every year at the end of the year for 5 years, we did present value of an annuity. And so that annuity table is on 688, right? So I'm going to kind of have to scroll down here. Okay, so here's the online equivalent of page 688 in the book. And as you can see, this is present value of an annuity. All right, present value of an annuity. So that's an annuity, right? The same cash flows coming every year. And in this case, we were looking at 5 years at 11%, right? So I come and I find my factor, and it's 3.696. All right, so that's what I'm talking about when I say finding the factor. Is you're in the book, you can go to the book table online, you can go online. If you're just using an Excel spreadsheet, it's built in. So that's what we're talking about when we're doing these present values. And it's important to understand that if you haven't done this before, that would be probably a weird concept to just spring on you. But the idea is a dollar that you get 5 years from now is not as good as a dollar you have today right now. So we have to discount it, right? So now we're going to look at the same problem, but we're going to look at each individual year's cash flow, because you don't always have the same cash flow. Like, you can't really necessarily use the present value of an annuity. You may have to use the cash value for each separate year. So in this case, it's the same thing. We're going to be have this contract that pays us $750,000 a year, but we have to subtract out some costs. So we basically end up getting $80,000. We have to put out $160K to buy the machine. We tie up $100,000 of our capital. We do have some expense in the third year regarding maintenance of the machine. And then at the end of the fifth year, we just sell it for $5,000. So we got some cash coming in and out here. And we're going to use that same discount rate, 11, right? And do the same thing. All right, so as you know, right now, we're investing up front now, $160,000 and $100,000. And those don't get discounted because they're now, right? That's the point of discounting, is to bring the value to today. So here we are, this is it. So our present value of the cash flow out right now is the present value of the cash flow out, 160 and 100. All right, so what happens next is we do the cash years for years 1 through 5, right? And so here they are. All right, here's our cash flows, right? So here's what we played out, and now we're going to get some cash flows in. All right, we're going to get our 80,000, except for in year 3, where we're really only going to net 50, because remember we had that 30,000 we have to spend on relining the machine, I think they called it, some kind of maintenance. So we got 30,000. And so our really net cash flow in year 3 is only 50, but here's our factors, right? Here's our factors we looked up from that table, and our cash flows, and you extend them, you do your extensions, and here's all your cash flows at present value. So 80,000 a year from now is 72,000 today. Year 3, so the reason we're showing you this is because we don't have exactly equal cash flows every year. So if you for some reason had a contract that paid different, like let's say you contracted to provide something and you provided more of it in some years than others, so your cash flow would be different in different years, you would have to do it this way, right? You couldn't just do that present value of an annuity, because an annuity assumes you're getting the same amount every year. And you're not always getting that. So in this case, in year 3, they just netted out that 30,000, right? And looked up the factor, and there's our year 3. So when all is said and done, we still end up with the same net present value that we did the other way when we used the present value of an annuity table. Okay, positive net present return like we have means we're even getting more than the discount rate. So our initial investment of 160,000 plus 100,000 working capital, we end up getting more than 12%, because it has a positive net present value. If it was a negative net present value, it doesn't mean there's not a return. It just means the return is less than the discount rate, which in this case was 11. So we're not making 11%. So if there's like a reason we want to make 11, like say that's our cost of capital, well, then we wouldn't do it. Okay, so if net present value is positive, great, higher than return. If it's 0, well, that's acceptable because that means we're getting exactly 11%. If the net present value of the cash flow is 0, we're getting exactly the discount rate as a return. And if it's negative, no, that's not good. We're getting less than the return we want. So this means it's super important to choose a good discount rate, right? Because that makes a big difference. And so the discount rate impacts the factor that you apply, and that affects your net present value. So what typically gets used is cost of capital, or cost of capital plus some amount, right? Because if you're only making your cost of capital back, then what's the point of borrowing that money or whatever? So cost of capital is just the average return you have to pay your creditors. So if you borrow money and you're paying 5% on that money, well, you need to make 5%. And hopefully you'd make more. You would say, well, my cost of capital is 5, but on my investments, I want to make 6. Right? So you use 6 as your discount rate, right? Or my cost of capital is 5, but interest rates have gone up a whole lot, and I can invest in a treasury bond and get 7% risk-free. Why would I do anything that's less than 7%, right? So you would use 7% as your discount rate. So it's choosing the discount rate is part of the deal. The nice thing about NPV is it actually includes getting back your investment and then tells you how much return you're going to get, right? So let's look at one more example of doing this. We have a little hospital and they're going to invest maybe in an x-ray machine, and it's going to cost them $31.69. That x-ray machine will last 4 years. It won't be worth anything when they're done, so no cash flow at the end for the salvage. And we'll get $1,000 more every year for 4 years. Should we do that? Well, cash flow out right now, right, is at 1, right? It's now, so you don't have to discount it. It just is the amount. So $31.69 present value of my cash flow out to buy the machine. Then every year for 4 years, I get $1,000, and there's no salvage value, there's no maintenance, nothing else. That's it. $1,000 for 4 years. Now it looks like it might be $4,000, but we have to discount it. So I go to that chart, right? So let's go to the chart and look up for year 1, 2, 3 at 10%. All right. So I'm gonna share my screen. Okay, so this is not a value of an annuity. I need to go to value of $1, right? And 10%, right, for year 1 is 0.909, for year 2 is 0.826, for year 3 is 0.751, and year 4 is 0.683. All right, so there's our factors. So we get our factors, and we come back here and we go back to our initial problem. Okay, so here we are. We've filled those numbers in here, and there's our rates, and we come up with these numbers. So when you add 909, 826, 751, and 683, those happen to total 3169. Great. Now, that's a 0 NPV. Remember what we said. When there's a 0 NPV, we do it because the return is exactly equal to our required rate of return, right? So that means we're going to get our capital back, our 3,169 plus 10%. So we would want to actually do this, right? This implies the cash flows are sufficient to recover 3,169 plus 10%. So we do it. This is great. I know it says 0 here, but that we've factored everything in. We factored in getting back our investment. We factored in that we want 10%. And so everything's cool. All right. So we're going to stop with the net present value stuff there. And we are going to move on to internal rates of return. Another way of looking at this. Keep in mind this. We want to invest when it's a 0 NPV. And we'll be back with the IRR on the next video.